Okay, so this is the key to test one. And number one, you want to solve the following equation. Now, this is a rational equation, although it is linear. There are no variables in the denominator, just real numbers, 2, 3, 3, and 2. So what you want to do here is to clear your denominators. You want to clear your fractions. So you got to find the LCD. So the LCD here is going to be 6. Now what you're going to do is multiply both sides by 6. Now notice there are two fractions here and two fractions here. So we're going to enclose those sides in parentheses. So we can have 3x divided by 2 minus x minus 2 divided by 3 equal, and then over here that's 2/3 plus x plus 5 divided by 2. And then so we're going to multiply this side by 6 and this side by 6. Okay, so the next step is to distribute. Do not reduce first. Do not say 2 into 2 is 1, 2 into 3, 2 into 6 is 3, and distribute the 3. That's incorrect. So you have to distribute first on both sides. So then you're going to get 6 times 3x divided by 2, so 6 times this fraction, minus, and then 6 times this fraction as well. Now what you need to do here is put this in parentheses, because when you reduce, you have to distribute, and you reduce, that's going to be a 1, that's going to be a 2, so you have to distribute a -2 through here. So you do need to put that in parentheses. And that's going to equal, and then over here, that's going to be 6 times 2/3 plus, and then 6 times, again, put this in parentheses, just like you did this one. This needs to be put in parentheses. X plus 5 divided by 2. So again, put that in parentheses. Okay, so now we're going to reduce. So we distributed first, now reduce. So now reduce, 2 goes into 2 one time, 2 goes into 6 3 times, and you get 3 times 3x, which is 9x. Okay, over here, when you reduce, that's going to be 3 into 3 is 1, 3 into 6 is 2, but you are going to distribute this negative through 2 through here. So -2 times x is a -2x. A -2 times a -3 is a +6. And that's going to equal, and over here reduce this, so 3 into 3 is 1, 3 into 6 is 2, so 2 times 2 is 4, plus, and then reduce this, 2 into 2 is 1, 2 into 6 is 3, and then you're going to distribute this +3 through here. So 3 times x is 3x, and then 3 times 5 is 15. Alright, so that's where we're at. So notice I have a linear equation with no fractions in it. Okay, the next step is combine like terms. 9x minus 2x is 7x, so that's 7x plus 6 equal, and over here I can combine the 4 and the 15, so that's going to be 3x plus 19. Alright, so to solve a linear equation, you're going to bring all the variables one side, constant the other. So let's go ahead and subtract 3x from both sides. And so I'm going to get 7x minus 3x is 4x plus 6 equal, combine like terms here, I get 19. And then subtract 6 from both sides, combine like terms, I get 4x equal 19 minus 6 is 13. And then to get the variable x by itself, I'm going to divide both sides by 4. 4 divided by 4 is 1. 1 times x is x, so I get x to be 13/4. So 13/4 are, what's that, 3 1/4? Okay. Alright, so that was number 1. Okay, number 2. Now this time you want to solve, and this is a rational equation. So you do have variables in the denominator, so one of the things you need to do is to factor your denominators if you can. So the x plus 3 here I can't do anything with. It's a linear binomial. The GCF is 1. Here the same thing. Now here I can factor this. That's the difference of two squares. So when I factor x squared minus 9, I get x minus 3 times x plus 3. Okay, so now we got to find the restriction. So we need to know what's going to make these denominators 0. So if you look at, let's start with this one here. What's going to make this 0? Well, if x is 3, I'm going to get 0 because 3 minus 3 is 0. And basically all you do is you take each of your factors listed in the denominators and you set them equal to 0. So x minus 3 equals 0, so x equals 3. That means x cannot equal 3, because if x were 3, that would make this 0. Over here, you say x plus 3 equals 0, and so x equals negative 3. So negative 3 cannot be x, because it'll make the denominator 0. And over here, we've already taken care of this, because this factors x plus 3, that's this one. And this factors x minus 3, and that's this one. So the restrictions are only 3 and negative 3. All right, so now we got to find the LCD. So remember, the LCD has to include every factor in the denominators. So here's an x plus 3. It occurred once. I'm sorry, x minus 3. It occurred once, did not occur any here, and occurred once here, so I need one of them. Then the next factor you see is x plus 3. It occurred once here, none here, so I need 1. So the LCD is x minus 3 times x plus 3. So that's going to clear your fraction. So when you multiply both sides by that LCD, these denominators will clear. Okay, now on the left side, just like you did with the previous one, there are two fractions here. So we're going to put that in parentheses, kind of like 2x divided by. Now don't leave it as x squared minus 9. You need to use that factored form. So x minus 3 times x plus 3 plus 3 divided by x plus 3. And remember, that's being multiplied by the LCD, which is x minus 3 times x plus 3. And that's going to equal, on the other side, since that's just one fraction, I'm just going to leave it as that fraction. So I don't need to put parentheses around that side. But I do still need to multiply by the LCD, because what I do to one side, I have to do to the other. So that's x minus 3 times x plus 3 times that fraction on the other side. So that's 1 over x minus 3. Okay. All right, now, just like we did it before, we're going to distribute this LCD through here. So I'm going to get x minus 3 times x plus 3 times the first fraction, 2x divided by x minus 3 times x plus 3, plus, and then the LCD times the second fraction, so x minus 3 times x plus 3 times the second fraction, equals, and then I'm just going to rewrite this side. So x minus 3 times x plus 3 times 1 over x minus 3. Okay, so now the next step is to reduce. So notice that the x minus 3's divide out here, x plus 3's divide out here, so all you're left with is 1 times 2x. And so 1 times 1 times 2x is 2x. Plus, okay, and over here, the x plus 3's divide out, and you're left with 3 times 1 is 3, and then 3 times x minus 3. So that's what you're left with. This right here is this. And that's going to equal, and over here, the x minus 3's divide out, you're left with 1s in their places, so factors of 1, and you have 1 times x plus 3 times 1, which is just x plus 3. All right, so notice that this side right here is just this. Now over here, I'm going to distribute the 3, and so I'm going to get 2x plus 3x minus 9, 3 times negative 3 is negative 9, equals x plus 3. Okay, so I clear the fractions. Now I have a linear equation. I'm going to go ahead and combine these two first, so that's going to be 5x. So you have 5x minus 9 equal x plus 3. And now I'm going to bring all the variables one side, constant the other. So I'm going to subtract x from both sides. So I get 4x minus 9 equal 3. When I combine like terms, that becomes 0. This is 4x. Adding 9 to both sides, I get, and combine like terms, I'm going to get 4x equal 12. And so divide both sides by 4, I get x equal 3. All right, so this is my proposed solution. So I'm saying that this proposed solution is x equal 3. But remember, now 3 is a solution to this linear equation. But remember, you're solving this original equation here, this rational equation, and notice that 3 is one of your restrictions. 3 actually makes your denominator 0, actually two of the denominators 0. It makes this 0, and it makes this denominator 0 as well. So remember, this right here, that's an extraneous root. Okay, so it's a false solution. So it is a solution to this equation, to the linear equation, but it's not a solution to the original. because because it makes the original undefined when you substitute 3 into x. All right, so then since that was the only proposed solution, I can't use it. Remember, you have to say no solution. But that's the work you had to show. Okay, now number 3, you want to solve the following equation. It's linear. Now you're going to distribute the -4 here, and you're going to distribute the 3 here to get rid of the parentheses. Now when I do that, I'm going to get 2x. A -4 times x is -4x. A -4 times a -3 is a +3, and that's going to equal -5. 3 times x is 3x. 3 times 1 is 3, and then minus x. All right, so all I did at this point was use the distributive property. Now combine like terms, I get 2x minus 4x is a -2x plus 3, equal over here, I get a +3x and a -x is 2x. A -5 and a +3 is a -2. All right, now bringing the variables one side comes to the other. When I subtract 2x from both sides, I get a -2x, and a -2x is a -4x plus 3 equal, that's 0, and you're left with -2. Subtracting 3 from both sides, I get a -4x equal -5. Let me go ahead and put that here. So -4x equals -5. Dividing both sides by -4, I get x to be a negative divided by negative is a positive, so I get 5/4. All right, so that's your solution. All right, now remember, if an equation has at least one solution, it is a conditional equation. So it's a conditional equation. So this equation is true under the condition that x equal 5/4. All right, number 4. Okay, so now you're dealing with complex numbers. So here you're subtracting two complex numbers. So again, this is subtraction. It's not addition. It's not multiplication. It is subtraction. So you got to remember, if you want to rewrite this, you got to remember that subtracting this means the same thing as either adding at the opposite, or you can say subtract -1 times 2 minus 3i, and then distribute the -i. But also remember that this right here, you can add the opposite. So remember, you want to change subtraction to addition, so you can say that's going to be 3 plus 5i plus the opposite of every term in here, so that's -2 and then a +3i. And they combine like terms. And you remember, you don't put it in standard form. So remember, standard form is a plus bi. That's standard form, a plus bi. So a is your real number part. So 3 and a -2 is 1. 5i and 3i is 8i. So you get 1 plus 8i. Now, if you had done it this way by distributing -1, you'll get the same answer. Because watch, 3 plus 5i, a -1 times 2 is a -2. A -1 times a -3i is a +3i. And again, put it in standard form. Real number part, imaginary part second. So 3 and -2 is 1. And then 5i and 3i is 8i. So again, you get the same answer. Okay, and over here, you're multiplying these two complex numbers. So you can use the FOIL method. So 2 times 3 is 6. So again, using FOIL. The outer 2 times 5i is 10i. The inner, a -3i times 3 is a -9i. And then the last, a negative times a positive is a negative. 3i times 5i is 15i squared. Now, one of the things you got to use, you must use the fact that I squared equals a -1. Right, you have to remember that. So that means that this right here is a -1. That's what that means. That's a -1. And so when I combine like terms, well, let me go ahead and rewrite it like this. So I'm going to get 6 plus 10i minus 9i. All right, remember that's -1. So remember that's -15 times I squared. -15. You can think of this as -15 times I squared because that's adding the opposites, adding a negative 15. So negative 15 times I squared is negative 1, so that's negative 15 times a negative 1, which is just a positive 15. And so, writing it in standard form, you're going to put the real number part first. 6 and 15 is 21. 10i, and then your imaginary number, your imaginary part. So 10i minus 9i is just I. So you get 21 plus I. Okay, now over here, you had to use the idea of conjugates because you wanna get that I, that imaginary number, out of the denominator. All right, so that's the idea. So you had to use the idea of conjugate, and so the conjugate of the denominator is 3 plus 4i. So all you do, remember, is just take just change the sign of the imaginary part. So the conjugate of 3 minus 4i is 3 plus 4i. Okay, so now what we're going to do is we're going to multiply the numerator and the denominator by the conjugate. And when we do that, and we do all the work, that's going to get rid of the I that's in the denominator. Okay, now in the numerator, notice this numerator times this numerator. So this is a monomial times a binomial. So you're just going to use the distributive property. So you're going to say 5i times 3 is 15i, and then plus, so if you want to do the work here, you can. So that's 5i times 3 plus 4i. That's what that is. And so distribute, you get 15i plus, and then 5 times 4 is 20. I times I is I squared. And then you got to remember that I squared is a negative 1. And so you get 15i plus 20 times a negative 1. So you get 15i minus 20. All right, so that's the numerator. So 15i minus 20. The denominator, remember those are conjugates, so remember what happens there. So 3 minus 4i times 3 plus 4i. So when you use the FOIL method, remember the outer and the inner are going to cancel out. Now you can do all of it, but you will see that the outer and the inner will cancel out because those are conjugates. So if you do the FOIL, 3 times 3 is 9. The outer is a positive 12x. 3 times 4i is 12i. The inner, remember, these are conjugates, so when you multiply the inner, you can get a negative 12i, and that's where they cancel. A positive 12i, negative 12i becomes 0. And then, I don't have enough room here, but you're going to have a negative times a positive is a negative. So that's going to be a negative. Put that here. And 4i times 4i is 16i squared. Okay? And so remember, I squared is a negative 1. And so you're going to get 9, and then a negative 16 times a negative 1 is going to be 9 plus 16. A negative times a negative is a positive. And so you get 25. So the denominator is 25. That's my denominator. Now remember, you want to put this in standard form, so that's important to have seen. So standard form means A plus BI. So I'm going to put that negative 20 first, and I'm going to say divide by 25. 25. And then plus the imaginary number part second. So we have 15i over 25. And then reduce, so that's going to be negative 4/5 plus, and that's going to be 3i divided by 5. So I get negative 4/5 plus 3i divided by 5. All right, and so that's in the form, that's in standard form because that's a plus bi. All right, now that was number 6. Okay, number 7, you want to solve this quadratic, now this is quadratic, so you want to solve this quadratic equation by factoring. So if you're going to solve by factoring, you're going to have 0 on the other side because you need to use a 0 factor property. So at some point, you're going to use a 0 factor property. And so when I rewrite, I'm going to get 6x squared plus 11x minus 10 equals 0. And remember, when factoring, you want to see if you can factor out a GCF other than 1. In this case, the GCF is 1, so I can't do anything in terms of factoring out the GCF. So I'm going to go directly to the two binomials, and I'm going to use the fall method. If something doesn't work, you just try something else. So let's go ahead and try, let's just try 6x and x for right now. So 6x times x is 6x squared. The last sign here is negative. That means one's positive, one's negative. We're going to figure that out in a little while. But I need a 10. I need these last two numbers to multiply to give 10. So let's try 5 and 2. Now, do not put a 2 here, because if you put a 2 here, that would mean that this binomial has a common factor of 2, which meant the whole original problem was divisible by 2, and it's not because of the 11. So let's put the 2 here and the 5 here. Now, let's do the outer and the inner now. So the outer is 12x, and the inner is 5x. And remember, the last sign's negative, so that means that these signs are different, so you're going to be subtracting 12x minus 5x. There's no way it'll give you 11x. So what that means is that 6x and x are not the ones I'm going to use. So then let's use 3x and 2x and see what happens. And then for 10, let's use 5 and 2. Now, I'm not going to put the 2 here because of the same reason that I could factor out a 2, which meant that you could have factored out a 2 from the beginning. So let's put the 2 here and the 5 there and see if that's going to help. And that's equal to 0. So the outer this time is 15x, the inner is 4x, and yes, it's going to work because when I remember the last sign's negative, that means these signs is different. So one's positive, one's negative, and the larger of these will take the middle sign. So that means 15x would be positive, and the 4x would be negative. And notice that 15x and a negative 4x is 11x. So that's going to work. I just got to make sure I put my signs correct. So the only way I can get a positive 15x here is if the 5 were positive. And the only way I can get a negative here is if the 2 were negative. Alright, so I factored this correctly. Now what I got to do is use a zero factor property. So I'm going to set each factor equal to 0. Each factor equal to 0. So I get 3x equal 2, so x is 2/3. And I get 2x equals negative 5, so x is negative 5 halves. And so that's going to go here. So x equals negative 5 halves, comma, 2/3. All right, now, don't put this in parentheses. You're going to leave it like this. Okay, and over here you can use quadratic formula. Here's you're going to solve this quadratic equation using quadratic formula. Here's the formula. And it's already in standard form, so you already have 0 on the other side. So all you have to do is determine a, b, and c. So a is 2, the coefficient of x squared. B is 6, the coefficient of x. And the constant is 7, so c is 7. And all you do is just plug numbers back into this. And notice it did say to simplify if possible. Simplify the radical if possible. Okay, so I'm going to get x equal the opposite of b. If b is 6, the opposite of 6 is a negative 6. Plus or minus the square root of b squared. So b is 6, so I'm going to put that in parentheses. I'm going to square it. Minus 4 times a, and a is 2, times c, which is 7. All over 2 times a, and a is 2. All right, so that's what I have at this point. Now we'll go ahead and simplify the radicand. Remember that also in the quadratic form, this is called the discriminant. So I get negative 6 plus or minus the square root of 6 squared is 36. A negative times a positive times a positive is a negative. 4 times 2 is 8, and 8 times 7 is 56. All over 2 times 2 is 4. 36 minus 56 is 20, so I get negative 20 rather. So I get negative 6 plus or minus the square root of negative 20 divided by 4. All right, so that's where I'm at. So now we got to figure out what the square root of negative 20 is. We got to simplify that because remember it says simplify radicals if possible. All right, so remember the square root of negative 20 means the same thing as the square root of negative 1 times the square root of 20. So that's going to be I times, now a perfect square that goes into 20 is 4. That's the largest one. So that's 4 times 5. And so we're going to get I times the square root of 4 times the square root of 5. And then square root of 2 is, square root of 4 is 2. So get I times 2 square root of 5. And we rewrite this with the I in the middle. So it'll be 2I square root of 5. And so that's what this is right here. So I'm going to get negative 6 plus or minus 2I square root of 5 divided by 4. And then I'm going to simplify this because I noticed that negative 6, 2, and 4, they all have 2 in common. So I'm going to divide everything by 2. So negative 6 divided by 2 is negative 3, plus or minus 2 divided by 2 is 1. So you're really left with I square root of 5 all over, and then 2 divided by, or 4 divided by 2 is 2. All right, and it didn't, you can leave your answer like this. It did not say to write as two separate fractions. So we can say negative 3 plus or minus I square root of 5 over 2. And then there are a bunch of other ways. You could say negative 3 plus I square root of 5 all over 2, comma, negative 3 minus I square root of 5 all over 2. You could break it down into two fractions. You could say negative 3 halves plus or minus I square root of 5 over 2 even. Okay? All right, so that was number 8. Okay, number 9, you want to use the square root property. So it is in that form. Remember that something squared equal a number, so you can use the square root property when it's in that form, and it is. So I'm going to go ahead and rewrite this. So I get 2x minus 3 squared equal 8. All right, so remember what you got to do is you got to undo the squaring part. So the opposite of squaring is the square root. So I'm going to take the square root of both sides. What I do to one side, I do to the other. Now remember, you are taking the even root of both sides. So remember, that's where that plus or minus come into play. So you had to put a plus or minus there. And then the square and the square root undo each other. So you get 2x minus 3 equal plus or minus. And then you have, remember it says simplify radicals. So you had to simplify the square root of 8, which is square root of 4 times 2. And the square root of 4 is 2, so you get 2 square root of 2. And so that's plus or minus 2 square root of 2. All right, so adding 3 to both sides, combine like terms to get 2x equals 3 plus or minus 2 square root of 2. And then dividing both sides by 2, I'm going to go ahead and rewrite it here. 2x equal 3 plus or minus square root of 2, 2 square root of 2. So divide both sides by 2. The 2's divide out, you get 1 times x is x equal 3 plus or minus 2 square root of 2 over 2. Okay? So that's one of your answers. So 3 plus or minus 2 square root of 2 over 2. Now don't make the mistake. Mistake is this, and some of you probably will if you're not careful. So here's the mistake. So what someone's going to do is they're going to see these 2's here, and they're going to reduce like this, and that's incorrect because if you reduce, remember you have two terms, this term and this term being divided by 2. Okay, so when you say 2 into 2 and write this as a 1, that's incorrect because 2 also has to be divided into 3. So that's not correct. All right, so you cannot do that. Now, if you broke it down into two fractions, like this, like what I'm about to do, 3 halves plus or minus 2 square root of 2 over 2, then you could notice that 2 into 2 is 1. Okay, so then you could say, well, that's going to be 3 halves plus or minus square root of 2. All right, because the 2's divide out. All right, that's square root of 2. Okay. Now, the next one, we want to complete the square. So the coefficient of x squared is already 1, so that's what you got to check for. Before you complete the square, you make sure that's a 1, and it is. If it was not, you divide every side by you would divide both sides by that number. In essence, it would be every term being divided by that number. So in completing the square, you want to bring the constant to the other side. All right, so something like this, and then you're going to add something to both sides, and that's what you're going to figure out. What is that got to add to both sides? So when completing the square, once this is a 1 right here, once the x squared is a 1, you're going to take the coefficient of x, which is -2. You're then going to divide it by 2. Always divide by 2. And that's going to be -1. And then you're always going to square that number. And so when I square that number, I get 1. So I'm going to add 1 to both sides. So that's what you add to both sides. This is what you add to both sides. Now, if you're doing this correctly, this should now be a perfect square trinomial. So in other words, I can write it as a binomial squared. And you can, because that's really x minus 1 times itself is this. And then -3 plus 1 is a -2. So now this looks like this. So now I can use the square root property. So I'm going to get x minus 1 squared equal a -2. So I'm going to take the square root of both sides. Don't forget the plus or minus. So the square and the square root undo each other. So I get x minus 1 equals plus or minus. Now remember, the square root of -2 is the square root of -1 times the square root of 2. And the square root of -1 is I, so I get I square root of 2. There's nothing else you can do with this. So it'll be I plus or minus I square root of 2. And then adding 1 to both sides, I get x equal 1 plus or minus I square root of 2. And I'm done. That's all you can do with this. So 1 plus or minus I square root of 2. Okay, number 11, you want to find the discriminant. So remember the discriminant is b squared minus 4ac. That's the discriminant. A, and make sure it's in standard form before you find a, b, and c, and it is. So 0 is on the other side. So a is the coefficient of x squared. So a is 3. B is the coefficient of x, so that's 4. And c is your constant, so that's -8. And so plugging everything back into the formula, I get b, which is 4 squared, minus 4 times a, which is 3, times c, which is -8. And so 4 squared, 16. A negative times a positive times a negative is a positive. 4 times 3 is 12, and then 12 times 8 is 96. So make sure you understand why that's a positive 96, because a negative times a positive is a negative times a negative is a positive. And so 96 plus 16 will give you 112. All right, so then you got to ask yourself, well, what is 112? Is 112 a perfect square or not a perfect square? All right, so that's what you got to ask yourself. Well, 112 is a real number, so it's not negative, so it's a real number, so it's going to either be a rational solution, or we can say this equation is going to have a rational solution, 2 rational solutions, or 2 irrational solutions. Right away, we can say it's not deep because this thing's not negative. And remember, when you take the square root of a negative number, that's where you get the I, so you get that complex solution. So the square root of 112 is not a perfect square, so this is not a perfect square. All right, so when it's not a perfect square, remember you're going to get a square root in the answer. You get a square root in the answer. Okay, which is going to make it 2 irrational solutions, make it irrational. Okay. All right, so here you want to solve the equation. You want to solve this equation. So you have 4 terms. It's already in general form or standard form. So you have 0 on the other side. And you're going to group the first 2 and group the last 2. So in the first group, I can take out an x squared. And I get x squared times 2x minus 1. So that's the first group. Always check yourself. X squared times 2x is 2x cubed. X squared times a -1 is a negative x squared. From the second group, I'm going to take out a negative factor. So I'm going to take out a -6. I can factor out a 6, in this case a -6. And so we've got to ask ourselves, well, -6 times what is a -12x? Well, that's going to be a positive 2x. And remember, if you're doing this correctly, what you're going to get in here is going to be the same thing as this one. And so -6 times what is a positive 6? Well, -6 times a -1 is a positive 6. And you're going to say equals 0. then you're going to factor out from here, you're going to factor out the common factor, which is 2x minus 1, and you're left with x squared minus 6, and that's equals 0. Now, don't think that those second factors is because of the difference of two squares. First of all, that's not a perfect square here. 6 is not a perfect square. All right, so you're not going to factor this, but you're still going to use the zero factor property. All right, so that means I'm going to take each of these factors and I'm going to set it equal to 0. So 2x minus 1 equals 0, and then x squared minus 6 equals 0. And then all you do is solve each equation. Now notice this is linear and this is quadratic. Now this is an easy quadratic because there's no x term. There's no x term. So I get 2x equal 1, so x is a half. Over here I get x squared equal 6. Now to get x by itself, I'm going to go ahead and rewrite this. To get x by itself, you're going to take the square root of both sides, and don't forget plus or minus. So the square and the square root into each other, so I get x equals plus or minus, the square root is 6, and so that's going to be your solutions. So my solutions are 1/2, square root is 6, and negative square root is 6. Those are your solutions. Okay, number 13. You want to solve this radical equation, but notice that the radical is already by itself. So now what you're going to do, let me go ahead and rewrite this. So now what you're going to do is you're going to square both sides. So remember, whenever you have a radical, to solve the equation, once you get it by itself, to solve the equation, you're going to raise both sides to a power that's equal to this index. So my index here is 2, because remember square root, so that's 2. If this were a cube root, you would cube both sides. Okay, and so the square and the square root into each other, so you get 30 minus x equal, and then x times x is x squared. So you went from a radical equation to, and remember this is quadratic now, so you went from a radical equation to quadratic. To solve a quadratic equation, you're going to bring everything to one side, so you're going to put it in standard form. And I'm going to go ahead and transpose this when I'm done. Actually, let's do it now. Let's go ahead and transpose the side. So I get x squared equal 30 minus x. So I'm going to bring everything to one side. And so when I do that, I'm going to get x squared plus x minus 30 equals 0. So I'm going to bring these two terms to this side. So that to bring the 30 over, I'm going to subtract 30. So that's why you see subtract 30. And over here, I'm going to add x. That's why you see plus x. All right, now this is factorable. So let's go ahead and factor this. So it'll be x. Now remember the last sign's negative and the middle sign's positive. So the last sign's negative. That means the signs in here are different. And you want to try and find factors of 30. So like 6 and 5, 10 and 3, 15 times 2, and so on. But let's try 6 and 5. All right, so always check the outer inner because you want this to be a positive x. So my outer is 5x. My inner is 6x. And remember, last sign's negative means these signs are different. And the larger of these will take the middle sign. So 6x has to be a positive. So that means negative 5x. 5x has to be negative. Now when I combine these, always check yourself. 6x minus 5x, is that a 1x? And the answer is yes. So this is correct. I just have to put the correct signs in. Well, the only way I can get a negative 5x here, the only way I can get a negative 5x is if this is x minus 5. And the only way I can get a positive 6x here is if this is x plus 6. And so you're done. Well, factoring. Now we're going to set this each factor equals 0, so using the zero factor property. So when I set each factor equals 0, I get x plus 6 equals 0, x minus 5 equals 0, and so solving each equation, I get x to be negative 6 and x to be 5. Okay? All right, now remember, when you raise both sides of an equation to even power, you have to check. So when you raise both sides, of an equation to an even power, you have to check for extraneous roots. All right, so you have to check for extraneous roots. So for example, see that negative 6? Let's check negative 6. I'm going to go ahead and check it here. So let's check. All right, so you go back to the original. So my original was the square root of 30 minus x equal x. All right, so wherever see an x, I'm going to plug in negative 6. So I get the square root of 30, subtract a negative 6, and I want to see if that's going to equal a negative 6. Well, 30 subtract a negative 6 is 30 plus 6, so that is the square root of 36. But the question is the square root of 36 equal to a negative 6? The answer is no, because this is 6. That's not negative 6, so they're not equal, so there's no. So what it means is that I can't use negative 6 because that's going to be an extraneous root. So notice that negative 6 is a solution. It's a solution to this equation right here, and you can check it. Negative 6 times itself is 36. 36 plus a negative 6 is 30, and then 30 minus 30 is 0. So it does check. It is a solution to this, but it's not a solution to the original. So that's why you always have to check for extraneous roots when you raise both sides to an even power. And 5 will work, because if you check 5, watch what happens. 30, square root of 30 minus 5, and we see that's equal to x. So where we see the variable x, I plug in 5. So I get, well, that's 5 right here. So 30 minus 5 is 25. And the question is, the square root of 25 equal to 5? And the answer is yes. So my only solution is 5. So 5 goes in this blank. So don't say no solution, because there is a solution. It's this one only. So it's 5. Okay, now the next one is an absolute value equation. Remember, when solving an absolute value equation, you have to get the absolute value bars by itself. If you don't, and you split them apart like we're about to do, you're only going to be getting one of your solutions. You're not going to get the other solution. So you're going to lose a lot of points, at least half those points. So what you got to do is subtract 3 from both sides first, and so you get absolute value of 2x minus 1 is equal to 4. So that's what this becomes. And then from here, you're going to write this as two separate equations. So remember, two separate equations. So you're going to say 2x minus 1 equals a 4. So now you're going to write it without the absolute value bars. So you're going to say 2x minus 1 equals a 4. And then you're going to say 2x minus 1 equals the opposite of the other side. So this is going to be a negative 4. So you got to remember that. So to rewrite the absolute value equation, you're going to split it up into two parts. So all you do is you can take the expression that's between the absolute value bars. Notice you rewrote them. So that'll be your left side in both cases, equal. And then the first one, you just read what you see. So it's 2x minus 1 equals 4 without the absolute value bars. The second one, it's the expression in the middle between the absolute value bars. That goes here. And then you're going to take the opposite of 4. So that becomes negative 4. Okay, now let's solve these linear equations. So I'm going to add 1 to both sides. And so I get 2x equals 5. And so x is 5 halves. So that's one of your solutions. Now you don't have to check for extraneous roots here. That's not necessary here. With the time constraints, I'm just go ahead and just not check them. So that's 5 halves. And over here, I'm going to add 1 to both sides. Combine like terms, get 2x equal negative 3. And divide both sides by 2. I get x to be negative 3 halves. So that's your other solution. So solutions are 5 halves, comma, negative 3 halves. Okay, now number 15, you're dealing with inequalities now. So just like if those were equations, you would distribute in both cases. You would distribute. And so negative 4 times 3 is a negative 12. Negative 4 times a negative x is a positive 4x, and then minus 8. And that's going to be greater than or equal to, distribute here, you're going to get 7x. 7 times negative 2 is a negative 14, and then plus x. All right, so the first thing you have to do is distribute. Okay, now combining like terms, I'm going to get 4x. A negative 12 and a negative 8 is a negative 20. Is greater than or equal to, and then 7x and x is 8x minus 14. Bringing the variables to the left, constants to the other side, I'm going to subtract 8x from both sides. So you would solve it just like you would in an equation. 4x and a negative 8x is a negative 4x minus 20, and that's going to be greater than or equal to, and then these combine to give you 0, and so that's going to be greater than or equal to negative 14. Now adding 20 to both sides, because we're trying to get x by itself. So add 20 to both sides. And so I get negative 4x is greater than or equal to a 6. And so now dividing both sides by negative 4. Now remember, since I divide by a negative number, I got to reverse this inequality symbol. So I get x is less than or equal to negative 3/2. All right, so that's x. So x, your solutions will be less than negative 3/2. So the number line, negative 3/2, is about negative 1.5. So that's about in the middle of negative 1 and 2. And it's pointing to the left. So it looks something like this. And then you shade it in. Okay, with the arrow. So make sure you shade it with the arrow. Interval notation, read a graph from left to right. So this thing is pointing towards negative infinity. Always parentheses with infinity and negative infinity. So it's parentheses negative infinity, comma, all the way to this x value, which we found to be negative 3/2 with a bracket. All right, so that's number 15. Okay, number 16, this time you have an absolute value inequality. So when you have an absolute value less than inequality, you have to write it, you need to write it as a compound statement. You cannot write a greater than as a compound statement. It has to be separated into two sets of equations. All right, so you got to remember that. So over here, since that's a less than, I'm going to say 2x minus 3 is less than 5. Now remember, that one I can write as a compound statement. So I can put this in the middle of these two inequalities. And at the same time, it has to be less than, it has to be greater than negative 5. So notice 2x minus 3 is less than 5, so that's easy to get from here. And 2x minus 3 has to be bigger than a 5. Okay, so we got to get the variable, we got to get the variable x in the middle. So I'm going to add 3 to all parts. Negative 5 plus 3 is a negative 2. Is less than, these combine out, and you're left with 2x rather. And that's less than 8. 5 plus 3 is 8. Okay, now, I'm going to go ahead and rewrite this. Dividing both sides by 2, I am now going to get my solutions. So negative 2 divided by 2 is 1. It's less than or equal to. So 2 divided by 2 is 1. 1 times x is x. And it's going to be less than, and then 8 divided by 2 is 4. Oops, I'm not sure why I put less than or equal to, so that's just less than. All right, so I kind of had this all covered. So we're going to divide both sides by 2, all three parts by 2. So negative 2 divided by 2, 2x divided by 2, 8 divided by 2. Simplifying this, I'm going to get negative 2 divided by 2 is a negative 1. It's less than x, and it's less than 4. So on the number line, you're going to put negative 1 with parentheses like this. You're going to put 4 with parentheses like this, and you're going to shade in every number between them. All right, now the interval notation, just read it from left to right. So let's go from left to right. I'm going to get parentheses negative 1, comma, all the way to 4 parentheses. Just note that there are an infinite number of solutions in here. So there's your decimals. You have 0.225, 0.3337, and so on. So you have all these decimals in here. Okay? All right, so that's going to take care of the key to this test, so to test 1. So that's the key to test 1.